Let's investigate this Shiny app comparing the mean and the median for a data set. Notice I'll leave these options kind of as default there. What we're doing is we're looking at a sample of data points displayed as dots up above in the gray area there, and then displayed as a histogram and a box plot down below, along with some descriptive statistics. Notice we can kind of slide the sample size that we want to choose. We generally kind of play with a variety there, but I'll leave it at 30 for now. And you can press the green button here to regenerate a new random data set. We'll mostly look at skewed and a bit at bell-shaped distributions, but you can always create your own just by clicking some points in a gray area if you want to investigate that. Supply your own values by pasting a data set in there, or look at some not as common ones in our course, things like a uniform data set where it's roughly an even chance of getting within each group, and or something like a bimodal data set where we see clumps of data in not just one area, but more than one area there. As far as skewed data, maybe that's a good place to start. Notice that we talked about a right skew versus a left skew versus symmetric data. If we assume, and this is going to generate some data that should be right skewed, if we assume that there's a right skew or a positive skew to our data, notice what's happening when we compare the orange triangle, which is the mean, versus the yellow circle being the median of our data set. Looks like for this first sample, we see that that mean is higher. So if we regenerate a few, those two are a lot closer together. These are a little further. We're seeing, in this case, the mean actually happened to be a little smaller, but we're seeing overall, most of these samples have a mean that's at least a little bit higher than the median. And that doesn't really change when we increase our number of sample size there. Maybe if we bump it all the way up to 200, you'll notice that they're kind of consistently closer together, but also a little bit more consistently, the mean is above the median. This is true because for a right skewed or a positively skewed data set, we see a cluster of data on the left or on the smaller area, but there is a large contingent of data points. There are more than expected data points that fall above that group as well. And so those larger data points are sort of pulling the average or dragging the mean in that right or positive direction. Whereas the median is a little bit more resistant to that. Since there are so many data points grouped up on the left area, the median isn't really going to be as affected by a few data points that are larger than expected. If we kind of reverse that and switch to look at a left skew distribution, we see the opposite situation where the mean is smaller than the median somewhat consistently because we have a group of data that's kind of near the top end, whereas some not necessarily outliers, although it looks like they're plotting one here. Some data points are lower than what we'd expect, which are causing the average or the mean to be brought down. And again, we see that relatively consistently. As you might expect with a roughly or approximately symmetric data set, you might see that it's kind of hit or miss, right? We can't really predict whether the mean or median would be higher because for symmetric data, they should be roughly the same. Obviously, these are random samples, so it would be unlikely for us to get one where they're exactly equal. But we're expecting the mean and median to be somewhat close together. We will look real quickly at this bell-shaped distribution. Remember those bell curves or those normal distributions. We're not seeing an exactly normal distribution here because we're just generating random data, but especially as our sample sizes go up, we're seeing that we do have that rough bell shape forming in most of these cases. And in pretty much all cases here, we're seeing that the mean and median are very close together. They're, again, not exactly the same because of random selection here of data points, but they're generally very close together. And that's because, among other types of symmetric distributions, the bell-shaped or the bell curves are one of those, right? So we would expect the mean and median to be roughly the same there.